Our next speaker is Anthony Goldbloom. Anthony is founder and CEO of Kaggle, he will be speaking about the COVID-19 machine learning challenges.
Hi, everyone. I'm Anthony Goldbloom, CEO of Kaggle. For those of you who don't know us, we are the world's largest machine learning community. We have a little bit over 4 million members, and we're best known for running machine learning challenges, but we also offer a place for data scientists and machine learners to share data sets and also to share reproducible notebooks or reproducible code. Like a lot of teams or a lot of people at the moment, we were interested in ways that we could contribute to COVID-19. 2.5 weeks ago, the White House Office of Science and Technology Policy approached us with the challenge that they wanted to put out in front of our community, and that's how we first got involved. Right now, we have 3 challenges running. Three challenges. One is an NLP challenge, which is an automated literature review. The second is a forecasting challenge, forecasting cases and fatalities. And the third is a data sets challenge, so curating useful data sets. I'm going to go through each of these challenges, give you a sense for what's involved, what they require, as well as what the kinds of things that we're seeing out of them. So the first one is this NLP challenge, which was the one that the White House Office of Science and Technology Policy asked us to launch. What they had done is they encouraged the journals to open access the history of articles they have published on coronaviruses, and then more modern articles on COVID-19 specifically, and also to release them in a machine readable form. One of the challenges is that the literature on COVID-19 is moving very, very quickly, and it's very difficult for somebody to get their arms across all of the literature. And so the goal here is, the way I like to position it is, it's like trying to create an automated literature review that each week, as new papers come in, the data set is getting updated, and we're creating the machine learners in our community sort of answering key questions about COVID-19 by scanning those papers, and in doing that, creating sort of like an automated literature review. If we look at the kinds of approaches that people are taking, this is an example of a system. It's not animating, but the way it works is somebody types in a question and it pulls out all the best answers to that question. Other people are taking more traditional approaches. So looking if we're trying to find all the papers that reference a reproduction rate or the reproduction number, doing string matches, looking for the papers that have that term, and then trying to extract the data out of those papers. And what we are doing is we are putting the best of what the Kaggle community is coming up with on a website. It's listed here at the bottom, www.kaggle.com, COVID-19 Contributions. And the aim here is for this to be a resource that people can come to have a sense for what the scientific literature is saying at any point in time. Our second challenge is a more traditional Kaggle challenge. It's a forecasting challenge. And here we're asking our community to forecast cases and fatalities by city. Now, the goal here actually isn't to build another epidemiological model. We heard from Ryan at CMU earlier today. There are lots of good epidemiological models out there. Actually, the reason we have launched this challenge is to encourage our community to play with the data and try and pick apart the factors that are driving differences in transmission rates across cities. So this challenge is much newer. The NLP challenge launched a little over 2 weeks ago. This one's around a week old, and so the models aren't quite as mature. But some of the early things, this is a very common output from a lot of the models that are being built here. It's what's called a feature importance plot. And it's interesting because this is giving us a sense for what the machine learning models are finding are the most predictive of fatalities and cases. At the moment, the models are this is one of the better performing models. You can see it's a very simple model. The most important variable is a time series variable, days from the first case, but it's also picking up that country, state, latitude, and longitude make a difference. Obviously, there's nothing about the fact that it's not the country that is the reason that transmission rates are different in different countries, but rather it's the policies in that country, or it's the the cultural norms around hugging and kissing, or it's the temperature. And so we expect that as people iterate on their models, they'll bring in more granular data sets, and we'll start to see much more interesting, these variable importance plots becoming much more interesting and starting to sort of pick apart the most important factors that are driving differences in transmission rates across different cities. So this is one to watch. The last challenge that we're hosting is a dataset curation challenge. So our community, as well as being very good at building natural language models and forecasting models, they're also very good at playing with datasets and curating datasets. Very often it's not so simple to join two datasets together. You've got geolocation challenges, or you've got, you don't have good join keys between different datasets. You have to do fuzzy matching. And so we've challenged our community to put together data sets that are useful for making decisions about the pandemic. To make this a little bit more concrete, I'll give you a sort of real world example of where this could be useful. So the congressman this morning mentioned that his understanding was that temperature had an impact on transmission rate. And this is one of the studies that is very often referred to when people say that temperature and humidity seem to reduce transmission. But this paper was written on 100 Chinese cities. That is a very, very small analysis. Whereas somebody in our community has taken every single city in the Johns Hopkins University dataset, joined that city to the nearest weather station, and so in doing that, he has created a dataset where you could very easily, or relatively easily, analyze the link between temperature, fatalities, and cases across every, the 4,000 cities, or whatever number of cities it is in the Johns Hopkins data set. And so this is a data set currently sitting on our website that would allow somebody to build a much more robust model around the connection between temperature and transmission rate. So to conclude, for those of you who are machine learners who are looking for a way to get involved, you can check out our challenges at kaggle.com/COVID-19. For those of you who are interested in following either the automated literature review, the things that come out of the forecast, insights that come out of the forecasting challenge, or the data sets being created on Kaggle, visit kaggle.com /COVID-19 contributions. We're also interested in getting input from domain experts. We found that having domain experts help to steer the work of our community has been very helpful for producing more impactful results. So I encourage you to email me at a@kaggle.com. Thank you very much.
Thank you very much, Anthony. That's a great and inspiring activity where many hands are working together.